On the cosmic scale, Earth is a tiny and almost insignificant speck, yet humanity convinces itself that it comprehends the vastness of the universe simply because we have the ability to observe portions of space using telescopes. Our sophisticated computers analyze the colossal amounts of data we receive, and from these calculations, scientists make educated guesses about what's happening far out in space, both physically and chemically. We piece together narratives about the formation of stars, the intricate movements of celestial bodies, and the origins of the universe itself. These constructs, derived from observations and theoretical frameworks, are what we term science. However, when a space probe ventures beyond the familiar, into previously unexplored regions, and returns data that suggests something groundbreaking or even monumental, some in the scientific community are quick to dismiss it. The reluctance stems from an inherent caution, perhaps an ingrained skepticism, toward the possibility of encountering an entirely new force or intelligence lurking in the dark, unfathomable expanse of space. Voyager 1 and Voyager 2 are prime examples of this. As two of the most successful space exploration probes ever launched, they have traversed distances once thought unimaginable. These spacecrafts became the first human-made objects to explore the outer reaches of our solar system. In 2012, over 3 decades after its initial launch, Voyager 1 crossed an extraordinary threshold, the point where the sun's influence weakens and the mysterious interstellar medium begins. This moment marked the first time a human-made object touched the infinite darkness of space, where silence and emptiness reign across 95% of the known universe. Many had underestimated the sheer possibility that Voyager 1 and its twin Voyager 2 would witness such a historic event, yet there they were, pioneers, heralding humanity's exploration into the unknown. What lies beyond the heliosphere, the immense bubble created by the sun's magnetic field that envelopes our solar system, differ significantly from the vast expanses between the stars. Beyond Earth's orbit, when we think of the space we can observe with telescopes like Hubble or the more recent James Webb Space Telescope, we are still within the realm of solar influence. The space beyond the Kuiper Belt, billions of kilometers away from the sun, behaves differently. Here, solar radiation and magnetic forces lose their dominance, and only in these far-off regions does the true void, the interstellar medium, begin. For a long time, scientists had only theories and models to predict when and where Voyager would reach this point. There was little in the way of hard data, and the measurements from the spacecraft defied expectations. Instead of recording the expected sharp drop in particle density, Voyager registered an increase in magnetic forces that were still connected to the sun. This suggested that there was a kind of stagnation zone, where the sun's solar forces clashed with the interstellar medium, forming a thick buffer, something that had not been predicted by earlier models. Fast forward to 2015, and Voyager 1's data revealed something even more perplexing. The probe sent back information so unusual that it left the mission scientists baffled. NASA officials attempted to reassure the public that this was an expected occurrence, given the advanced age of the spacecraft, yet some began to suspect there was more to it. Perhaps Voyager had encountered something far bigger and more profound than previously thought. The probe's data became incomprehensible, leading to speculations that Voyager 1 might have entered a region where conventional notions of space and time no longer applied. Not long after this period of confusion about the probe's location, Voyager 1 detected a faint plasma current, a thin, almost imperceptible stream of charged particles, where there should have been nothing but empty space. This phenomenon, dubbed by some as a plasma mystery, puzzled the scientific community. Official explanations attributed it to a small amount of superthermal electrons, particles moving at speeds faster than thermal equilibrium would dictate, yet others remained unconvinced. Could this bizarre plasma current indicate something far more mysterious, hinting at a previously unknown force within the interstellar medium? Some researchers proposed that Voyager 1 might have stumbled upon plasma waves in areas where no such phenomenon should exist, igniting debates about whether this was evidence of an undiscovered force within space itself. Although NASA insisted on more conventional explanations, there were those within the scientific community who urged caution, warning against the dismissal of novel forces or phenomena just because they didn't fit neatly into existing models. These researchers argued that if humanity truly wanted to explore the space between the stars, we had to be prepared for encounters with the unknown, forces and mysteries that defy the tidy boundaries of our current understanding. Nevertheless, mainstream scientific circles, and NASA itself, seemed hesitant to embrace such unconventional ideas. The reluctance to challenge the established notions of physics reminded some observers of the human tendency to compare new experiences with familiar patterns. It's akin to arriving in an unfamiliar country, only to judge everything based on what one has read in travel guides. In a detailed report on the Voyager 1 mission, NASA engineers described how they had to dig through blueprints that were decades old to resolve the latest batch of transmission problems from the spacecraft. By using an onboard computer that hadn't been operational for years, they managed to fix a problem where corrupted data was being sent. The quick thinking and ingenuity of the Voyager team ensured that the probe would continue its journey, but both Voyager 1 and Voyager 2 are running out of power. The expectation is that their power levels will dwindle to the point where communication with the spacecraft will cease sometime around 2025. After that, these cosmic explorers will drift silently into the cosmos, beyond the range of our instruments. As of now, Voyager 1 is over 23.3 billion kilometers from Earth, sending back data at a painfully slow rate of just 160 bits per second, enough, however, to capture essential measurements of the interstellar medium. Though it has been nearly a decade since Voyager 1 crossed into the interstellar space, the spacecraft remains within our solar system. The distant Oort cloud, a vast region of comets and icy bodies still gravitationally bound to the Sun, marks the outer boundary. This cloud lies so far from the Sun that it will take Voyager 1 another 300 years to reach it. Yet in 2023, Voyager 1 surprised scientists again. The spacecraft transmitted an enigmatic combination of ones and zeros, data that baffled the mission team. This wasn't the first time Voyager 1 had sent back strange information. Twice before, it had returned data that defied explanation. One such instance occurred when it reported the plasma current in the interstellar medium, a phenomenon that shouldn't exist according to current scientific understanding. Within the heliosphere, particle density hovers around 100 particles per cubic centimeter. Outside of it, scientists had predicted finding only a single particle per cubic centimeter. Yet Voyager 1 discovered a much higher density of particles than expected, and on one particularly remarkable occasion, it recorded an entire stream of plasma in the interstellar medium, a region where nothing was supposed to exist. Some initially dismissed this as a measurement error, but others speculated that it might be evidence of something much more profound. One theory was that a stellar flare, an eruption from a distant star, had somehow traveled through the vacuum of space, an exceedingly rare and puzzling occurrence. Flares from our own Sun, for example, typically only reach the boundary of the heliosphere and don't extend into interstellar space. The idea that a plasma stream from a distant star could have reached Voyager 1 suggested the possibility that our understanding of the interstellar medium was incomplete or flawed. In 2021, another issue arose with Voyager's data transmissions, which seemed to come through garbled and unreadable. NASA's engineers worked quickly to diagnose and correct the issue, discovering that the problem stemmed from faulty telemetry data related to the spacecraft's attitude control system. By rerouting the control system, they were able to restore the probe to normal operation, but it was yet another reminder of the challenges that come with communicating with a spacecraft located billions of kilometers away. The continued operation of the Voyager probes is nothing short of a testament to their resilient design. However, as time passes, their power sources, the plutonium-based generators, produce less and less energy each year. Most of the instruments on board have already been turned off to conserve power. NASA hopes to maintain contact with the probes until at least the end of the decade, but even when communication is finally lost, these spacecraft will continue their silent journeys, serving as emissaries of human civilization. The golden records they carry, inscribed with sounds, images, and messages from Earth, were designed to introduce humanity to any alien species that might one day encounter the probes. Although the odds of such an encounter are astronomically slim, the symbolic value of these records remains. The Voyager mission stands as one of humanity's greatest scientific achievements, providing invaluable data about the outer planets and the boundaries of our solar system. Every transmission from these spacecraft expands our understanding of the cosmos, but also humbles us, reminding us how much we have yet to learn. As the Voyagers drift deeper into space, beyond the edge of the heliosphere, they may very well be uncovering phenomena that force us to reconsider some of our most fundamental assumptions about the universe. Their greatest discoveries might still lie ahead, waiting to be revealed in the silent, dark expanse of the cosmos. NASA's ability to re-establish communication with these spacecraft, despite their immense distance from Earth, is a testament to human ingenuity and perseverance. Even in the face of failure, like when Voyager 2 faced its own transmission crisis in 2022, the Voyager team's quick thinking brought the probe back online. In 2018, Voyager 2 approached the edge of the solar system and crossed the heliopause, mirroring the milestone that Voyager 1 had passed in.